Hello and welcome to Sarwin Style Coding. In this part of our Docker course, we're going to learn how to Dockerize our application by creating a Docker file from scratch. In a simple term, by writing a Docker image and defining a set of instructions, we can package our entire application, including the source code, the dependencies, and also the environment into a Docker image that can run consistently on any machine. In this video, we're going to build a Docker file for a React.js project, step by step, by full explanation for every part of the process. So by the end of this video, you will be able to understand how Dockerfile works in practice, and you will be able to Dockerize any application much more easily. So if you're ready, let's get started. In this part, we're going to Dockerize our application. Dockerizing is the process of packaging our entire application, including source code, dependencies, libraries, and configuration files into a single Docker image. The main advantage of this approach is probability. Once the image is built, we can run the application on almost any computer without worrying about the environment differences or missing dependencies. When we run the Docker image, Docker automatically create a container, start application, and make it accessible. To build this image, we need to create a file called a Dockerfile. A Dockerfile contains all instructions required to build and run the application, such as installing dependencies, copying project files, configuring environment variable, defining port, and defining the startup commands. Docker provides several important instructions for writing Docker files, including from, WORKDIR, copy and add, user, cmd, and entry point. In this video, I will explain each of these instructions step by step by real examples. Along with Docker commands, we will also use some Linux commands. So if you are not familiar with Linux, I highly recommend learning the basics. But if you don't have time to learn the Linux basics, don't worry. To write this tutorial, I will explain every Linux command I use so you can understand exactly what is happening in each step. Now, let's begin by creating our Docker file and adding into the project. Our project is very simple. It has a Node.js backend and React.js frontend. Once we're going to Dockerize frontend, so inside the frontend folder, we create a file named Dockerfile with capital D, and as you see, the icon changed to Docker image. Now it's time to start writing our Docker instruction inside the file. The first instruction is from. From instruction is used to choose the base image for our application. In simple words, it defines the environment our application will run on. The base image can be a simple operating system image, but in most real projects, the better approach is to use image of technology your application is built with. The reason is Docker images are built in layers, and most images already have their own base image underneath. So the node image already includes operating system and everything required to run Node.js application. If you are not sure which image you should use for your project, you can check the Docker docs. Docker provides complete example for many different technologies and framework along with their Dockerfile. For example, by looking at this example, you can easily understand Dockerfile is structured and which image is recommended for your project. For example, Python project usually use Python-based image, JavaScript project and Node.js project typically use Node.js based image, and for .NET application, Docker also provides official sample project and Dockerfile. For example, here in a app folder and inside the ASP.NET app, you can see the Dockerfile. In Dockerfile, you can see the base images ASP.NET, and as you see here, sometime an image includes a full registry path before image name. That usually means the image is hosted outside of the Docker Hub. In that case, beside the image name and tag, you also need to specify the registry address and where the image is stored. Now let's go to JavaScript section. For example, here we have a sample project that uses React Express and MySQL. If we open the front end and a Dockerfile here. As you can see, it uses the base node in base image node LTS. By exploring the rest of the Dockerfile, you can get a good understanding of how Docker images are built and how you can write a Dockerfile for your own project. Now let's come back to our project. Since our front end is built with React.js, we should use node image as our base image. But there is one very important thing you should avoid doing. Never use a base image without tag, for example, or using latest tag, because if you do so, Docker will automatically pull the newest available version from Docker Hub, and that version may not be compatible with your project, and your project might not work correctly. There is why always a good idea to check Docker Hub for choosing an image tag. Here on a node page, you can see images with different sizes, around 400 to 300, and others might be smaller. The reason is that the images are built in different Linux distribution, and the Alpine distribution is much smaller. So if I search for Alpine here, you can see the image size is only around 40 to 60 megabyte. Here I'm looking for Node.js version 24, and I choose the first one, the version Alpine 24. And now, before we add the Docker file, there is one more thing you should know. If you look carefully at each image, exactly provides a multiple compressed file with different sizes. Docker automatically select the correct version based on your operating system and CPU architecture. Then it download and install the version that matches your computer. Let's paste the tag here after the colon. And before writing the rest of the instruction, I want to build this image because you can clearly see what each instruction does and how it affects the final image. Now, let's build the image. Open PowerShell or terminal, then navigate to the directory where Dockerfile is located, and here you should write docker build -t. -t option allows you to define the name and tag for the image. I choose a custom name, React test app, and after the colon, I specify the tag v1. If you don't specify tag, Docker automatically assign the latest tag by default now, and a dot for specifying the Docker file location. And if you press enter, the Docker file is created and the image node is downloaded. Here, if you write the command docker image, as you can see here, my image is created and the version is v1. Now that our image has been created successfully, let's run it and create a container from it. To do that, I run docker run -it and I paste the container image name, which is React test app v1. And when I press enter, the container created, and we are in a node environment, as you can see, and can write the JavaScript command like console.log servin. And when I press enter, as you see, the servin, it prints servin in a console. And now I press .exit to exit the container, and let's see what file and folder exit inside the container. To do that, we need to open a Linux shell or bash environment inside the container. So I run the image again, but this time at the end of the command, I specify the shell or bash. Normally, many Linux distributions use bash. However, since this Node.js image is based on Alpine Linux, bash is not installed by default. So if I try to run bash here, I got error, as you see. Instead, I use sh for shell, which opens the default shell environment inside the container. And now we are inside the Linux shell and we can run Linux commands here. For example, I run ls, which is used to list files and directories. And as you can see, after I press the enter, it displays all the files and folders inside the container. And right now our application files are still not inside the container. So let's go back to Dockerfile and copy our project file into the image. In Docker, we have two instructions for copying files and folders, which is a copy and add. These two instructions are very similar. However, the add instruction provides some additional features that I'll explain later in this tutorial. For now, let's start with copy. The syntax is very simple. First, we specify the file or folder name. Then we define the destination path. So I want to copy package.json file inside the folder named app. So I add /app. But if you want to add multiple files, we can simply add file names separated by spaces. For example, I can also copy the readme file, readme.md file here. One important thing to remember is that our image is running on Linux, and Linux is case sensitive, so you need to be careful about the lowercase and uppercase letters when writing a file or folder names. Now, as you can see, Docker returns an error for app. That's because when you copy multiple files, Docker expects the destination to be a directory, so we need to add a slash on the end of the destination path to indicate the folder. We can also use pattern for selecting files. For example, I want Docker to copy every file started with package and ended with JSON. So I use star, which is the wildcard. I add the star after the package, and it's copy package and package lock.json. Now, for copying everything from the directory, including all files and folders, I can simply use dot, which represent the current directory. There is another useful instruction, which is WORKDIR. The WORKDIR instruction defines the default working directory inside the container and tells Docker all commands should run inside that directory. So I write WORKDIR and choose the app directory as a work directory. In simple words, it defines the location where the next Docker instruction will run. So after writing the work directory, I can simply add dot because the current directory is now /app. Now let's talk about file names that contain spaces. For example, let's change readme file to readme with space between read and me. If we write it normally, Docker will return an error because it treats space as a separator between arguments. For a situation like this, we should use array syntax. It means we place the files inside the square brackets and here. And then wrap each file names with a single quote or double quote and separate them with commas. Another important thing you should remember is that when copying multiple files, for example, when I add the file mongo.yaml here, the destination path should end with /. In this way, we tell Docker that the destination is it not file, is a directory. Now let's move on to, let's remove all of these and use dot to copy all files to the app folder. And now let's move on to the add instructions. We talked about earlier, we said that add is very similar to copy, but it provides a few additional features. One of these features is downloading files directly from URL. For example, if you have a file hosted online and you want to include it in your image, you can write the address by HTTP, like HTTP / and the path, and writing the file name, for example, test.php JSON and dot for destination, Docker will automatically download and copy the file into the app folder. Another useful feature is automatic extraction of compressed file. For example, if I write Docker and for example, I write a file, zip file like a.zip here and dot for the destination, Docker automatically extract the content of a.zip and copy all the extracted files into the app directory. Now let's remove the add instructions because while you don't need one of these features, try to use copy instead of add. Now let's build our image again from scratch. So I came back to the PowerShell and I moved to the directory with my Docker file is located, and here let's write Docker and build-t and React-test app v1 and dot. This time the build process take a bit longer because Docker is copying all the project files into the image. Now, as you can see here, the transferred content is around 300 megabytes. And now let's run the container. I use the command docker run -it React test app v1, and I want to run a shell, so I add the sh at the end of the command, and you will see that we are inside the app directory. This is because the WORKDIR instruction we defined earlier. So I use the ls. This command shows all files and folder inside the app folder. So you can see that the project files are now inside the container and our application code is fully copied into the Docker image and is accessible. There is one very important thing we need to talk about here. If we go back to Docker Desktop and check the React test app image, you can see that the size is around 473 megabytes, which is quite large since Docker images are usually transferred over network. Larger image takes more time to upload, download. They also increase the image build time. So the question is, how can we reduce the image size? If we go back to the project, remember that we earlier copied everything using copy dot command. The problem is there is also copied node module folder, which is very large, but we actually do not need to copy this folder because as long as we have package.json log, we can easily recreate it inside the container simply by running the npm install command. How can we exclude the node module folder when using copy dot? This is exactly where dockerignore files become useful, which is dockerignore works similarly to gitignore. Let's create this file. It starts with dot, and we write all the letters dockerignore with lowercase, and as you see the icon changed to Docker icon, and here we write the files and folder names which is we want to be excluded. I add slash for node module at the end of the node module to indicate it is a folder, not a file, and as well as we add the node module here. When we rebuild the project, this will be excluded. So let's exit here and let's run the build the image again. As you see here, the transferring content and it become very low, around 5.20 kilobyte. And let's clear here and go back to the running the image inside the shell, and let's run the command ls to see the files and folder. Here, as you can see, that node module folder is no longer inside the container, and that means our dockerignore file worked correctly. Now we need to recreate the node module folder inside the container by running the npm install command. So let's go back to Dockerfile. If we want to execute Linux or Windows command inside the Dockerfile, we use the run instructions. So here I write run and a command which is npm install. This means that during the image build process, Docker will execute the npm install command inside the container and the node module will be created. We can also run other operating system commands the same way. For example, we can write run apt install Python. But if we try this command here, it will fail because our images are based on Alpine Linux and Alpine does not use apt as its package manager. Instead, Alpine use APK. So we have to use APK for our image. For now, I removed this example and I try to build the image again. So let's move back to the here and let's exit the shell, and here I build the image again. Now if you watch the build process carefully, you notice that Docker completes the previous step very quickly, but npm install step keep longer because this stage is where Docker downloads and install the project dependencies on it. And now let's run the image in shell mode and let's run the ls command, and as you see here, our node module is created. Besides the run instructions, Docker also provides two other instructions for executing commands inside container: CMD and entry point. The syntax of CMD is different from run. Instead of writing commands normally, we usually write them in array format using square brackets and quotation marks, and we write the commands separated with comma. For example, I write npm comma start or install. But the real difference between run and CMD is it is not a syntax, it is execution time. A run is a build time instruction executed during the image build process, but CMD works differently. It runs when container starts, so it is a runtime instructions, and that is why the CMD command should be written at the end of the Dockerfile. And another important thing to remember is that we should only use one CMD instruction inside the Dockerfile. If we use multiple instructions and the Docker execute only the last one. Docker also provides other instruction called entry point. The syntax is very similar to CMD. It is also usually written in array format. However, there is an important difference between them. The CMD instruction can easily be overwritten when starting a container. For example, if our Dockerfile contains npm install, you can replace it at runtime with another command like sh shell or with echo hello when running the container. So when you run the container, the npm install is not executed and echo hello will execute it. But entry point behaves differently. It is not easily overwritten. If you want to replace entry point command, you usually need to explicitly use the -- entry point option when running the container. So if you want to replace the echo hello, you have to use -- entry point to replace it with npm install. So the entry point is more reliable instructions and help us to prevent main container command from being accidentally replaced by other command when a container starts. Now let's talk about environment variables. In our test project, we already using a environment variable. As you can see in API.js, we used React app API URL. As you can see, this variable stores the API URL used by our application. So we need to define this variable in our Dockerfile to work properly. So for defining the environment variables, we should use the env instructions. And as you see, we should specify the key and value. Our key is React app API URL, and for the value we usually don't need quotation marks around the value. If you want to define more environment variable, we simply write additional env instructions in separate line and provide their names and values. Now that we know how to define the environment variable, let's build the image again. As you can see, the image is built, but this time you notice that the npm install step again took a long time, and Docker didn't use that cache for that layer. Later in this video, I'll explain why it happens and how we can optimize it. Now let's run the image again and enter in shell environment. I want to check whether our environment variable was created correctly or not. For that, I use print_env command, which shows all environment variable in the container. As you can see, our environment variable is here and created successfully. Now let's talk about users. By default, Docker run application using the root user, which has the highest level of permission inside the container. However, in most cases, it is considered better practice to create and use user with more limited permissions. Otherwise, running everything as root can potentially create security risk. Now, for a simple project like this React.js application, creating a custom user is not really necessary. But creating custom user is an important Docker concept, so let's create a new user together and learn how it works. In Linux, we create users by running the add user command, and because it is a Linux command, we execute it using the run instructions. In Linux, users are usually associated with group as well. So first, let's create a group using add group command. I write add group, and I use -s option to create system group, and then give a group a name like app. And now I want to create a user itself. To write multiple commands inside a single run instruction, we can connect them using add sign. And then we use the second command, which is add user. After that, I use -s option to create a system user. And then I provide the username, which is app. After that, I use a -g option to specify group name, which is app. Usually, it's common practice to keep username and group name the same for simplicity. And finally, the user instructions. I specify that this point forward, the container should run using app user instead of the root user. Now let's move back to PowerShell and build our image again. Now let's run the container again, and this time I want to check which user is currently active inside the container. So I use the whoami command, and as you can see, the current user is app. But before we move on, let's run another command, which is ls-l. The L command shows the owner of files and folders. So let's look carefully. As you can see here, all files and folders owner is root. And it means that our app user only has limited access to this file. As you can see, it has the read only access. So we need to make change inside the Dockerfile to fix this properly. So let's move back to our Dockerfile, and here we need to, the first important thing is that user creation should happen earlier in Dockerfile layers. So I move the adding the user and group after the node import, and also add user after the WORKDIR. But if we try to build the image again, Docker return an error saying that app user does not have permission to perform the copy operation. The reason is that instructions like WORKDIR and copy are executed as root by default. And since we switch the container to use app user, permission problem starts to appear. So before using the app user, we need to assign ownership of the app directory correctly. To do that, we can use a Linux command, which is name is chown. For the running the Linux commands, we need to use run instructions. So I write here run, and for the command I write chown -r and app for user and another app for the group and /app for the folder. This command changes the ownership of app directory and assign it to app user and group. Now there is one more important thing we should improve, the copy command. We want copy instruction done by app user instead of root user, so we should add the chown option here, and as you see we should specify user and group. I write app for user and also app for group. So in this way, all project files and folders are copied with app user ownership instead of root. Now let's rebuild the image and test everything again. So I move back to PowerShell and rebuild the image. As you see, the image is built successfully. Now let's run it and run the command who am I. As you can see, the who am I, and as you can see the current user is app. Now let's check the file permission again with ls-l, and this time as you can see all project files and folder are owned by app user. So now the app user has the current permission to access and work with the project file inside the container. It's time for the final topic, optimizing our Dockerfile. So far everything works correctly, but you may have noticed something important. Every time we build the Docker image, the npm install takes a long time to run again. To understand why this happens, first we need to understand how Docker builds images. Docker process a Dockerfile layer by layer. Each instructions creates a new layer, and if a layer has not changed, Docker simply load it from cache instead of rebuilding it. But if a layer changes, Docker has to rebuild that again. And here is the most important part. When one layer changes, Docker not only rebuild the layer, but also rebuild all the layers after it. And this is exactly the problem happening with our npm install step. Before the npm install, we have the copy dot layer, which copied the entire project into our image. And because we still haven't added the Dockerfile itself into a dockerignore, even changing the Dockerfile can trigger this rebuild process. But we can optimize this very easy by reorganizing our Dockerfile. The idea is simple. Instructions that change less frequently should be placed higher in Dockerfile so Docker can catch them more effectively. So it's better to put the copy dot after the npm install, but there is still a problem because for running the npm install, we need package JSON and package log JSON to running npm install. So we split the copy command into the other command. We have to write copy package and package JSON log before npm install instructions. So I write here copy and this time I want to use pattern for copying the package JSON and package JSON log. I write copy I package star dot JSON and dot for copying the package and package JSON log, package log JSON to app folder. Also, we need to change the ownership by --chown and specifying the app user and app group. App column app. Now, if I build a Docker image, again, Docker needs to execute the npm install step once more, but from this point forward, as long as package.json or package lock.json do not change, Docker will load these upper layers from cache, and the build process will become much faster. Only when package.json or package.json lock changed, the Docker rebuilt the npm install layer again. Now let's move to the final step. And so far we have copied file, create custom user, create permission, and optimize the Docker file. But still there is one very important thing left: running the application itself. Our React application starts using npm start. And since it is the command, we should write it in a run command, but the main runtime command of the Docker should define using cmd instructions instead of run. So I write cmd, and inside the array format, I write npm start. And now let's rebuild the image again. I exit here, and as you see, image successfully built. This time when running the container, I no longer need shell mode. Instead, I use a port mapping. I map port 300 from host machine to port 300 inside the container, because our React application is running on the port 300. So 300:300, and now I should write the image name, which is React test app v1. And now if I open the browser and go to application URL, you can see that our React project is successfully running directly from the Docker image. As you see, the front end still cannot access the data because backend server is not running yet. In the next part, we will create a Dockerfile of our Node.js backend project, and also you will learn how to run all services together using the Docker Compose. So until the next video, take care and goodbye. Bye.